Okay, good morning. Welcome to
SuperMath number 75.
SuperMath75. So we found a very cool question in the review section of our book today, and so instead of doing it in the review, we're going to do it for a movie. If all altitudes in a triangle have the same length, must the triangle be equilateral? Okay, do you understand the question?
Yep.
All right. Let's just draw an arbitrary triangle. So we have this altitude is equal to that altitude is equal to that altitude. So that's our situation. So all those altitudes are equal. And the question is, does the triangle have to be equilateral? It's a very interesting question.
Well, we could look at a special kind of triangle.
Okay.
How about an isosceles right triangle?
All right, if that helps you, that'll be good.
So, I know that these altitudes are, because the sides are the altitudes,
Yeah.
so I already know that those two altitudes are the same.
Okay.
So how would we figure out if that was the same or not?
Okay, interesting.
So, I know this, it cuts it in half, like that.
Okay.
But this can't be the same. Because if it was, this side has to be 0, otherwise the Pythagorean theorem wouldn't work.
Yeah, very good. Very good observation. I'll tell you one other extra thing. In an isosceles right triangle, this altitude is also the perpendicular bisector, like you just noticed.
Yeah.
Right? But because this is a 45-degree angle, you get a 45, 45, 90 triangle.
Yeah, and then...
And that means this altitude is actually equal to half the... So put a 2 ticks on that. No. The altitude is equal, because these are both 45, 45, 90 triangles. Okay, so so you see, in your example, in the 45, 45, 90 triangle, it didn't work. You had 2 altitudes that were equal.
Yeah. Well, maybe we could look at an equilateral triangle and see if the altitudes are indeed the same.
Okay, I think we can probably do that without drawing it. What's a good argument that would show that in an equilateral triangle all the altitudes are the same?
Well, because you can just rotate the triangle so that all the altitudes equal all the other altitudes.
Very good. So a symmetry argument shows you that in an equilateral triangle they have to be the same.
But you can't do that here.
Right. So we're going for the opposite question here. So you've noticed that if it's equilateral, then they're all the same. We're doing the opposite now. If they're all the same, is it equilateral? So you can